Alright, so today we're going to get started on the third part of our coaxial indicator. This is going to be the shaft. I'm going to go ahead and do the shaft first before I convert over to the milling operations. Just go ahead and do the lathe, as much lathe work as I can before I have to convert. Pretty straightforward shaft. I am going to make a couple of modifications though, just for my own tooling and measurement purposes. The bore that we have on the body measures just a little bit over 15, whereas this calls for 15. So I'm going to cut it over a little bit, and I'm going to switch to imperial here because I want to use micrometers to measure this, and my metric micrometer that's 25 mil, I don't trust it. So I would rather use my my good stuff to measure it. I'm going to take the shaft down to 605, which is a little bit over my measurement, and then we can hand fit it from there. We should be within 2 or 3 thousandths of it. Other than that, everything's pretty straightforward. I'm probably going to reduce this 9.98 measurement a little bit because the collets that I'll be using this for are all in imperial, so I'll probably make this 3/8, which is a little closer to 9.52. So anyway, I think that's about it for this part. Let's get to it. Okay, well, I forgot to mention that I'm going to use a piece of stainless that I've had sitting around in the shop for a while. Like a lot of the stuff I do, I'm not sure where it came from. It is completely non-magnetic. It might have just a slight pull to it, but not much. I've also switched over to the 3-jaw chuck because it's a little less unwieldy and gives me a little bit more room to work in here. I've already turned a little bit of it just to make sure that I was going to get a good finish out of it, because I wasn't sure exactly what it is. You know, some types of stainless are really difficult to get good finishes on. You'll also notice that there is a hole in it already, and again, since I don't know where this came from, I don't know what that hole was for. Interestingly enough, it is the same size, 4mm, that needs to be in one side of this. Now there's a hole that goes in one side and a slot that goes in one side, the same side, at 90 degree angles to each other, and they're both 4mm. So it's very tempting for me to say, oh well, I'm cutting some time down, I've already got a 4mm hole drilled through here. However, looking at this kind of closely, I'm not quite sure that hole's centered on there. I'm going to cut that hole off, just so I'm not tempted to use it to line up things when I believe that it is not quite centered on the shaft. Hole's cut off. Okay, we're at 409. We're shooting for 393, 95, somewhere in there. So I'm going to let this cool down a little bit, and I'm going to redress this bit because I'm not really happy with the finish. Alright, I've switched to some different kit here. I just wasn't happy with the cut I was getting with that other high speed. This is a TCMT 3/8 carbide holder, TCMT cutter. Let's see if we get a little bit better cut with this. Okay, so we got a light press fit. I'll probably use a little bit of thread locker on there, or bearing locker on there to keep it, make sure that it stays in place. Okay, let me first start by saying I do not like turning between centers on this machine. The reason is because the tailstock just doesn't have enough length to give me comfortable movement with the cross slide. It can be done. It's not my favorite thing to do, but I've got it set up here. Kind of got the compound at a weird angle, and the tailstock's right up against the compound or the cross slide, and it's going to work, but I'm going to have to make a couple of adjustments. What I'm trying to accomplish here, though, is I want to make this pass in one sweep, but you know, I got a lot of stick out here, so I don't trust it just hanging out of the chuck. I got a lot of extra material. This is the end of my actual part right here, this line. So I got a lot of extra material, this line right here, just to give me some room to work here, but it's tight. It's going to be tight. So first thing I'm going to do is I'm going to use this little tiny parting type blade just to get in there and mark where my end of my part is. And then I'm going to come back with some sort of tool and do the rest of it. This is one of those instances I just love. So I got my tool straight on there. I like that. That'd be nice. Can get all the way from that side, and I get down to this side, and just as I reach the bottom of the part, oh, it's stuck. I could actually do it there, but I'd probably run into it. So let's adjust I'm going to cock the tool post a little bit, if I can find my wrench. I'll cock it a little bit like that. Let's see where that gets me. There's another thing I need to make for this lathe, is a positive stop. Okay, I got 2 or 3 millimeters past the part now. So unless I'm being a complete idiot, which is possible, I won't hit anything, and I can go all the way to the end there. I'm hitting right here. So I'm going to extend the tool out a little bit. Okay. So my compound slide is pretty square on the machine, but just as a make sure that I got it in the right position, I'm just using this little angle finder to make sure that I'm going at 45-degree angle. Okay, got the part out, turned it around, and now I can see if it's going to fit, and it is close, but will not go on yet. So I'm going to do some hand finishing. I'm going to hand fit it. Everything clean. Alright guys, I told you this was going to be I think I told you this was going to be an adventure, not a how-to video. I think this is a lesson in chucking and rechucking. So, what happened? And is it salvageable? Alright, the shaft is wonderful. Don't pay attention to this, it's because I'm moving it up and down. You may be able to see it already, what's going to happen. If I move it down the shaft and kind of lock it on, the end that I'm going to cut off is a little tighter, so I can actually lock it on right now, so it'll stay there. There's no movement in the back end on the shaft, on the hole and the shaft. There's no movement. Okay, check out what this face is. I think you can see that it's moving a little bit. Total movement is about a thousandth, maybe a little less than a thousandth. So I can live with that as far as the face, the reference face to the shaft. I can live with a thousandth. The shaft and the hole going through and this face, they're all square to one another. Okay? That's the important bits. However, watch what happens. See this? And this? Alright. You can take my word for it, that's a thousandth. Alright? The reference face is a thousandth. That's 10 thousandths right there. That's 20 thousandths right there. And it's about a thousandth right there. So, what that affects is, well, first of all, it affects that I can't stand looking at it spinning like that. But it also means that this hole, that this pocket up here is off, which means the bearing won't go down when the shaft is sitting on it. So, you know, I don't know if you can see it, but I can actually see that this section is actually leaning that direction. I've got the shaft really nice on there. I mean, it turns like butter. There's hardly any gap whatsoever. There's hardly any movement, and it just turns like butter. And I spent a lot of time getting that thing buttered in there, so to speak. Man, it's off. It's just so far off. And I didn't notice it till I started spinning it like this. And of course, you know, I'm fitting it, and just putting it on, taking it off. And then all of a sudden when it fits, and I'm like, oh cool, I can spin it now. And I start spinning, and I'm like, what in the hell? So alright, this video did not go as planned, obviously. Shaft looks good. I had planned to switch over to the mill and start on the cutout and the screw hole. Didn't get that far. I'm going to leave it at this point right now. I thought maybe leaving this attached for the time being until I determine how I'm going to hold it in the mill might be a good idea. But the problem is that we obviously have a problem with the body. Fits nice. Again, this reference is fine, but the upper part of the body, let's kind of just put the bearing on. You can see the bearing doesn't go down, and maybe you can see that it is off center. So something happened where this section of the body is askew. I'm sure it happened when I changed it in the chuck, and I don't know. I really don't know exactly why it did that, but I think I have a plan. I do have enough aluminum left to make another one, and my new plan is to do all the turning in one setup, except this register. I think if I cut this register, get it right for the thrust washer, but I'm going to leave it long. I'm going to leave it kind of sticking out here at the end, and enough to where that I can chuck it and then reach in here, cut this reference, cut the body, drill the hole, drill the bearing cup, all in one go. I'm more than likely just gonna move on. I'm gonna remake the part and move on to making the next part as well, and I'll just do a short video of remaking that part, because I mean, essentially all the cutting is the same, it's just the way the setup is going to be. So show you the finish on the shaft. For stainless steel, I think it came out pretty well. And like I said, it is not magnetic, so I'm 99% sure that it is stainless. On this channel I show the mess ups. I don't, you know, I could have just remade this part and said that was the part I made, and you would have never known that I screwed this up somehow. But that's not the way I do things. You know, I'm here for the adventure. I don't make how-to video. I don't make how-to machining videos. I make machining videos for the adventure of doing it, and share with you guys and get your guys' insight into it. So like, subscribe, all that good stuff, and we'll see you next time.